Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 6 of a unit motion in a plane. So let's begin with today's class. Today we are going to discuss about the projectile motion. This is part 2 of a projectile motion. In the previous class we were discussing about the what is projectile motion, what are the common terminologies that we are interested in, and we have derived the formula of the same, and we have done one of the numerical that include all this. So first let's just quickly revise the formula list and then moving on the next questions. So let's just quickly do with this. This is the formula list. What I know is that this is y-axis and this is x-axis. I have thrown my projectile with an angle theta with the horizontal while and moving with the velocity u. That what I have is it's a time of flight, it is a 2u sine theta by g. H max, it's an u square sine square theta by 2g. Range is u square sine 2 theta by g. Last, it's an equation of trajectory. This y is equals to x tan theta minus of half into gx square u square cos square theta. So this is all the common terminologies that we use very often while calculating the certain terms. Yes, so let's begin with the today's class with some new questions. First, if an object is projected with velocity u while making an angle theta with the horizontal, find out ratio of range to the maximum height. That is what they require. They said if an object is projected with velocity u while making an angle theta with the horizontal, find out a ratio of the range to the maximum height. So now first, what is range? I can write the range as it's in u square sine 2 theta divided by g. If I more simplify this, it's a 2 multiplied by u square multiplied by sine theta multiplied by cos theta divided by g, and the h max, it's a maximum height, it is u square sine square theta divided by 2g. It's an h max. Now I require a ratio of this, it's an r divided by h max. So if I take a ratio of this, it is a 2 multiplied by u square multiplied by sine theta multiplied by cos theta divided by g multiplied with h max or 1 by h max. It's an u square sine square theta divided by 2g. So if I solve this, it's a u square that has been cancelled, it's a g that has been cancelled. Here it is a sine theta, here it is a sine square theta, so one of the power has been gone. The what I remain with, it's a 2 into 2, it's a 4 divided by sine theta by cos theta, it's a tan theta. So this is very very important, that I can write like this, it's an r by h, I'm talking about the h max, it is equals to 4 by tan theta. Please write this, in your notebook, we are going to use this. Yes, these are the certain formulas, or we can probably we cannot say this as a formula because these are not the fundamental formulas, But these are the derived application, and from this derived applications, various competitive examinations ask the questions. So please write this. We are going to discuss as many as possible. Yes, but for that you must write it this all applications at a certain place where you can refer them, and once you go through referring them once, twice, thrice, and more than thrice, yes, you are going to remember this. Yes, and then you can use it simply, because in an competitive examinations we have not been provided ample amount of time that first you find out the ratio and then apply a formula. No, 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 this is not simply not possible. So you must remember that r by h max, it's a 4 by 10 theta. So would you like to do certain numericals based on this? Would you? Let's move on. What the data is all about, let's have a look. That if maximum horizontal distance of a projectile is 4 times maximum height of projectile, find out angle of projection. This is their question. Yes, go through this very carefully. What they say, it's a maximum horizontal distance of a projectile is 4 times maximum height of a projectile. What they require? They require find out the angle of projection. So what they say, maximum horizontal distance, it's a range, is 4 times the maximum height covered, it's in 4h. So this is r is equals to 4h, and what do you require? You require an angle of projection. Yes. So what I can do is that r by h is equals to 4 by 10 theta. Now what data is telling, it's an r is equals to 4h. So this 4h by h, this is 4 by 10 theta. Yes, this 4 has been gone, and as 4 has been gone, this 10 theta is equals to 1, and when 10 theta is equals to 1, this theta is equals to 45 degree. This is the answer. Yes, simplest. Yes, but it is the simplest after you know that r by h is equals to 4 by 10 theta. R by h is equals to 4 by 10 theta. Yes. So can you do this? Can you? One more question of same category. One more. Yes, let's move on. If range equals maximum height, find out angle of projection. Do it on your own. Do it fast. Do it. Yes, if range equals maximum height, find out angle of projection. How could you do this? What they says r is equals to h. Theta is required. So what I can write? It's an r by h should be is equals to 4 by 10 theta. So as r is equals to h, this should be h by h should be is equals to 4 10 theta. This is simply the one. H by h has been cancelled. Yes, and as it is 10 theta should be is equals to 4, so theta is equals to 10 inverse of 4. That's it. The task has been done. So I hope you are clear with this. Is it? Yes, are you clear with this? So can you do this kind of questions? Can you? Will it be possible? Are you sure? Great. Let's move to the new application through one of the question only. Yes, that what this is if an object is projected with 30 meter per second while making an angle of first 30 degree, second 60 degree with the horizontal, find out range in both the cases. So you need to find out the range, and you have been given that you can take g is equals to 10 meter per second square. So go for it. Yes, simply you have the formula of it. You have the formula of it, and you must know the formula. Do you? So what it would be? It's an u square sine 2 theta divided by g. So this is u square. It's a 30 square multiplied by sine 30 degree. It's a sine of 2 into 30 divided by 10. So if I solve this, it's a 900 divided by 10, that is a 90 into sine 60. Sine 60, it is a root 3 by 2. Yes, so this should be 45 into root of 3 meter. Is it clear? Is it clear? It's an r1 u square sine 2 theta by g. Now let's find out the r2. R2 is equals to u square sine 2 theta divided by g. Yes, it's a, if I put out the value of u square, it is a 30 square multiplied by sine 2 into 60 divided by 10. So this is 900 by 10, it's a 90. But if you don't know what would be the value of 120, how could you calculate this? If you don't know the value of sine 120, what it would be? Yes, you can write like this. It's a 2 multiplied by sine theta multiplied by cos theta. Yes, yes. Do you understand what I did here? It's a sine 2 theta that can be written as 2 into sine theta into cos theta. So this is it, that sine 2 theta can be written as 2 into sine theta into cos theta. So I did the same thing. It's a 2 into sine 60 into cos of 60 degree. Yes, this divided by g has been already used. So if I solve this, it's a 92, this is 180 multiplied by sine 60, it's a root of 3 by 2 multiplied by cos 60, it's a 1 by 2. So this is 2, this is 2, this is total 4, this is 180, so this will be 45 root 3 meter. This is range 2. This is range 2. I hope these things are clear to you. Is it? So if you remember the range 1, what is was? Look at this. This is 45 root 3 meter. Yes, and even here it's in 45 root 3 meter. Is it magical? Yes. How these two ranges are equal, even though if you look at this carefully, their angle of projections are equal. Yes, their velocity is same, but their angle of projection is equal. So did it happen every time? Did it? Yes, this is the case that will happen every time. So please remember this golden key points, that if object has been projected same velocity but different angles, such as theta 1 plus theta 2. I'm talking from the horizontal. Theta 1 plus theta 2 should be equals to 90 degree. Yes, if theta 1 plus theta 2 is equals to 90 degree, then its range will be always equal. Please remember this. Yes, both the time velocity must be equal with same velocity. Their angles could be a different. Yes, and if these two different angles are such as theta 1 plus theta 2, it's a 90 degree. If you remember, you called these angles as the complementary angles. Yes, so if these two are the complementary angles, that means addition of both these angles is 90 degree, then the range will be always equal. This is the case of every time this happens, every year time this will happen. I hope you remember this. Yes. So I want to have one more magic, that uh, let's say let's say that if particle has been projected with same velocity but different angle, so velocity would be the same and then angle would be the different. So let's say this is theta 1, this is theta 2, and we need to identify what would be the range, whether it would be a same or different one, something like this. So let's say first it's a theta is 30, here the theta is 60 degree, range would be the same. If it is a 45 degree, if it is a 45 degree, again this is the complementary angle, then the range would be the same. Let's say it is a 45 plus alpha, and it's a 45 minus alpha. It is theta 1, it is theta 2. So if I add this 45 plus 45 would be a 90, and this plus alpha minus alpha would be gone. So again that total is 90, and as the total is 90, it's the same. Now one more very interesting point is that let's say this is 30 degree with horizontal. My angle is 30 degree with horizontal, and theta 2 is the 30 degree with vertical. So if I directly add this, it's a 30 plus 30 is a 60. It's a not an complementary angle, but you must consider that this is with horizontal and the other one is with vertical. So when you consider an angle, you must consider it from somewhere, one of the place. If it is 30 degree with vertical, it must be 60 degree with horizontal. I hope you are clear with this. Yes, so it is 30 degree with vertical, that means 60 degree with horizontal. I hope you understand this very well. Yes, so this is 30 degree with the horizontal and indirectly 60 degree with the horizontal. So again the range would be the same. Yes, I hope you can do this kind of things very quickly. And this has been asked several times in both the examinations, in the JEE mains examinations as well as in the medical examinations, that AIPMT, even NEET has asked sometimes this kind of questions, that what find out the ratio of the range and something like this. So are you done with this? Are you done with this? Yes, this is the application number 2. Yes, let's move to the next application, and this is very important. This is very important. So let's move on then, again with the help of question only. That suppose if a particle is projected with speed u, but while making an angle of first theta and second 90 minus theta, find out first r1 is to r2, second t1 is to t2, third h1 is to h2. These are the cases that if a particle is projected with speed u but it is making an angle of theta and 90 minus theta, and I simply need to find out the ratio of the ranges, ratio of the time of flight, and the ratio of the maximum height, and I'm going to add things at here only. Yes, so let's first quickly go through this up to with this many information only, and then we'll move to the next level. That what I know is the u is the same in both the cases. My theta 1 is theta and my theta 2 is 90 minus theta, and first I required the range 1 is to range 2, as I know that these two angles are the complementary angles. I know theta 1 plus theta 2 will be theta plus 90 minus of theta. This would be a gone and this would be a 90 degree. So range 1 and range 2 would be equals, that we have done in previous slides only. So this is equals to r1 by r2, and that would be equals to 1. This is r1 is to r2, that would be equals to 1. Next, it's a time of flight. Next is the time of flight. T1 is to T2. Now what is the formula of T1? It's a 2u sine theta divided by g. And what is the formula of time of flight of 2? It's a 2u sine of 90 minus of theta divided by g. I hope this is clear to you. This g gone, this 2u gone, so whatever I am left with is the sine theta divided by sine of 90 minus theta. This is cos theta, and sine theta minus cos, so this is tan theta. Sine of 90 minus theta is cos theta, and this sine theta by cos theta would be a tan theta. Yes, what was your answer? Is it the same? Is it same? Are you done with this? Have you? Okay, great. Next, let me add something. It's a third. It's an h1 is to h2, the ratio of the maximum heights. Now h1 is u square sine square theta divided by 2g multiplied by u square sine square 90 minus of theta divided by 2g, and this 2g would be gone. This u square would be a gone. So this will be sine square theta divided by sine square 90 minus theta. It is a cos square theta. So this sine square theta divided by cos square theta, it is a tan square theta. So this h1 by h2, it is a tan square theta. Yes, are you done with this? So shall I add something to this? Shall I? So let's have a look. I need to find out the T1 multiplied by T2. I need to find out the T1 multiplied by T2. Then next is the relation of range with h1 and h2. This is all what I required. Yes, I required a t1 into t2, and I required the relation of range with h1 and h2. So let's work for this. Let's find it out. This first, the question number 4, which will give me a t1 into t2. So this t1, it's a 2 into u into sine theta by g, multiplied by t2, it's a 2 into u into cos theta. I hope you remember this because it is a sine 90 minus theta. So this is 2 into u into cos theta by g. Now let's try to rearrange this, that this is 2 divided by 1 of the g multiplied by this 2 into u, it's a u square, multiplied by sine theta into cos theta divided by g. Now tell me, what is this? What is it? Yes, this is 2 into u square into sine theta into cos theta divided by g. Yes, it's a 2 into r divided by g. Please remember this, it's a t1 into t2 in this case. It's a t1 into t2 in this case. In this case means that if projectile has been thrown twice, one with the angle theta, another with the angle 90 minus theta, or it could be any complementary angles. You can take this as a 30-60, you can take this as a 45-45, you can take this as a 45 plus alpha, 45 minus alpha, and all these cases can be considered here. You can take this as a 15-degree and 75-degree, even though you don't know the value of this, even though you don't know probably value of 15 or value of 75, you must know that this t1 into t2 must be equals to 2r by g, and h1 by h2 it's a 10 square theta, and t1 by t2 it's a 10 theta. So please remember this. This is the application, this is the very important applications, and so many questions can be found on this. Yes, are you done with this? Are you done with this? So let's move to the next question, because it is the that we need to find out the relation. We need to find out the relation of h1 and h2 with range. Yes, look at this, it's a relation of range with h1 and h2. So what is h1? It is a u square sine square theta by 2g. What is h2? It is a u square cos square theta by 2g. Let's multiply this. It is an h1 multiplied by h2. Then it can be u square sine square theta divided by 2g multiplied by u square cos square theta divided by 2g. Yes, and let's multiply this. Let's let's multi let's multiply this, or suppose let's take an square root of this. So this is root of h1 into h2. That would be equals to if I take a square root of this as well, this would be something like this. Yes, so this u square and u square would be u square only, multiplied by sine square theta into cos square theta. It is a sine theta into cos theta, and this 2 into g into 2 into g, this is the 2g only. Yes, so this is u square into sine theta into cos theta divided by 2g. Yes, are you done with this? Are you? So now let's do one more thing. Let's multiply this with the 4. So if it has been multiplied here, I need to multiply it here too. So if I do this, it's a 2g, it's a 2, this is 2. Yes, so the whatever I'm left with is 2 into u square multiplied by sine theta multiplied by cos theta divided by g, and if I am able to do this, it's an r, which could be written as 4 root of h1 into h2. This is range. This range R is equals to 4 under root of H1 H2. Please remember this. Yes. So can you do this? Is it possible by you guys? Are you sure? Are you sure? Can it be done? Can it be? Will you be? Yes, for sure. Okay, let's move to the next application. And before we go through the next application, let's find it out. That find condition 4. Condition 4, maximum height and maximum range. Condition 4, maximum height and maximum range. So let's begin with maximum range. First, maximum range. The range would be, what is it? It's a u square sine 2 theta divided by g. Now if you observe this very carefully, what you can change, look at this, there are certain limitation of changing u. G cannot be simply changed, so this could be maximum if sine 2 theta is a maximum. The range could be maximum if sine 2 theta could be maximum. Now what is the maximum value of sine of the any angle? I can say it's a 1. Yes, so sine 2 theta could be equals to 1. Now when sine value would be a 1, at what angle sine having a value of 1? It's a 90 degree. So what I can write is that 2 theta should be is equals to 90 degree. Yes, and if it is there, it's a theta would be equals to 45 degree. So if what I can write is that if velocity is same, then projectile can have maximum range if projected with 45 degree. Yes, this is the case that if I keep u as a fix, g what we consider it is always a fix. Yes, so if I keep a u as a fix, g as a fix, then my projectile having a maximum range if it has been projected with 45 degree. Yes, you might have studied this fact that this fact has been teach to the athletes as well, to the players as well, because for let's assume that some athlete is there and he is associated with certain throwing events. Yes, he needs to throw something so that it can travel a longer distance, so he or she must be taught this, that if you project this with the help of 45 degree with same effort, that means with same you can make your object to travel a better and to travel a far more distance. Yes, might be in physical education, probably in class 10 or class 9 somewhere you must have learned this, that if you have thrown this with 45 degree, this could be the better, or this could travel a longer distance. So please remember this, that if theta is equals to 45 degree while u is the same, my range would be maximum. I hope is it clear? Is that great? Next, let's move to this second. It's in maximum height. Let's find out the condition of maximum height. First, what is the formula of h max? What is the formula of h max? It's u square sine square theta divided by 2g. Now if I pick u as a constant, g as a constant, my maximum value will be there when sine square theta would be equals to 1. So if if sine square theta is equals to 1, if sine square theta should be equals to 1, that means if sine square theta is equals to 1, that means sine theta could be equals to plus or minus 1. But here I am talking about the plus 1 only, so the sine theta should be equals to plus 1 because I want the maximum value. When sine would be 1, its theta is equals to 90 degree. So if an object has been projected by 90 degree, it can travel a maximum height. So what do we mean by 90 degree? Let's look. If I have object thrown like this, look at this. It has made a 90 degree with the horizontal. Yes, this is the case. This is simply the motion in one dimension that we learned in previous class. Yes, in the previous unit, that means. Yes, so if velocity is fixed, then object can have maximum height if it is being projected by an angle of 90 degree with horizontal or 0 degree with vertical. Yes, this is the condition. This is the condition for maximum height. That if you throw this, if you throw this with the angle of 90 degree with the horizontal or 0 degree with the vertical, your height, your achieved height would be the maximum. So please do remember these things, and let's find out question that an object is projected with same velocity but different angles. Different angles with horizontal. Let's specify this so not have any doubts. With horizontal. Find out their relative ranges. Their relative ranges. Yes. Uh, I will let you know what a relative range is all about or what I would require. Suppose first it has been thrown with 50 degree. Second, it has been thrown with the 60 degree. Third, it has been thrown with the 40 degree. And fourth, it has been thrown. Fourth, it has been thrown with, let's say, 53 degree. Let's say this is range 1. Its range will be range 2. This would be a range 3. And this would be a range 4. Yes. Now, what you require is that which one would be the maximum range, which one would be the next to the maximum, and which would be the last, something like this. So you want to arrange your range. You want to arrange your range in the sum of the order, probably let's say increasing order or decreasing order, something like this. So how could I calculate or how could I find it out that which range would be higher, which range would be a smaller and something like this? How can I do this? Any idea? How can I do this and what can be done with this? Any assumption? Any assumption? What can I do and what I suppose to be know is that I know that range is maximum. Range is maximum if angle of projection that we call as in theta, it's a 45 degree. But here none of the case, here none of the case is of 45 degree. So what I can understood is that how much my angle is deviated from 45 degree. Lesser the deviation, please listen this word very carefully. Lesser the deviation, higher would be the range. Yes. So if I consider it's a, let's say it's a first case, it's a 50 degree, there is a deviation of 5 degree. Let's get third case, it's a 40 degree, it's a, again a deviation of 5 degree. So both have been deviated from 45 degree by 5 degree. Yes, one is the more than 5 degree, one is the less than 5 degree, but deviation, a change is of 5 degree only. So this range would be equal, so R1 must be equals to R3. I hope this is clear. I hope this is clear. R1 must be equals to R3. Now let's find it out the second case. It's a 60 degree. So our deviation here from 50 degree, deviation from 45 degree is of 15 degree. And the next is the case, it's a case of fourth, it's a 53 degree. Fourth, it's a 53 degree. So deviation from 45 degree is 8 degree. So here it has been deviated by 8 degree, here it has been deviated by 15 degree, and here this two have been deviated by 5 degree. So what I can know is that R1 and R3 having the maximum range, R1 equals to R3 having the maximum range, then R4 would be the maximum, and then least is the R2. This is in the decreasing order. Yes, it's a descending order. Yes, highest first and least would be the last. I hope this is clear. So do you understand this? Do you understand this? This is very interesting. This is very interesting, very logical. If we can reach to the logic behind this question, these are the questions of certain seconds. Yes, these are the questions of certain seconds. This question cannot take more than few seconds. Yes, so please remember this, all the applications, because these are very important applications. Yes, and very beautiful applications. Yes, that their applications and their numerical point of view, their importance is very good. So please go through this very carefully. Yes, now let's move to the next question. Again, a very logical question, a very logical question. So let's have a look at this. That suppose they say that equation of a projectile is given as y is equals to 8x minus x square. Find out range of projectile. You just pause the video, and try it. And if you cannot, then just play the video again and I would be there to help you guys. Yes, so just pause it. So let's begin with this. What can we do? It's an equation of a projectile is given, that this represents the y-axis, this represents the x-axis, and I need to find out the range. If you are thinking that let's suppose that this is y is equals to 8x minus x square, and let it to be compared with equation of trajectory. Yes, it is, and y is equals to x tan theta minus half into gx square divided by u square cos square theta. If you are thinking about this, that this is very bad idea, Please don't do this. This is not going to work at all. So please don't do this. That's why I rub it. Yes. Now think certain logical aspect of this. This is why this is x. This is my projectile motion. If you look at this, what I required a range. The range is on x-axis. When I am trying to find out the range, it is the displacement in y direction would be always 0 because I have started with here and I have ended up with here. So displacement in y direction while calculating range would be a 0. I hope you understand this. So this is 0. This would be equals to 8x minus of x square. So if I solve this, that 0 is equals to, let's take x as a common, and this is 8 minus x. So this could be x equals to 0 or x is equals to 8. This could be x equals to 0 or x equals to 8. Now x equals to 0, I know that from the diagram this x equals to 0, that x equals to 0 is this point, but x equals to 8 is this point. Here it is an x equals to 0 and this is x equals to 8. So my range is x equals to 8, and that's it. Yes, this has been done. Yes. So please remember this, all kind of applications, these are very good applications. Yes. So please, let's wind it up here. Please do as many questions as possible because there are many applications. There are many applications that even we have not touched them. Yes, I will try to cover as many as possible in the next class as well. But before you tune to the next, please go through the first part and second part of the projectile. This is very important. As well as one more request from my side is that please revise the lectures of the vectors as well, because vectors are a strength in class 11 as well as in class 12. Yes, it is going to help us in both the classes, so we cannot afford to forget them. Yes, so please revise them, please practice a lot, and this will save us. Yes, thank you. Have a good day. Take care. Bye bye.